Okay, today we're going to talk about direct variation. Direct variation is a linear relationship between two variables, x and y, that can be written in the form y equals kx, where k cannot equal 0. This is a proportional relationship. Last week we talked about proportional relationships. It is the same thing. So we have to find what k is. This can also be written as k equals y over x, which means y divided by x. The explanation here is the constant of variation, our k, in a direct variation is also known as the slope. We talked about slope last week. Slope is labeled as m. They mean the same thing. K and m are the same exact thing. All right, let's get into finding if it is a direct variation. So just like we did with proportional relationships, we're going to find the constant. So we're going to find k. And we do this by doing y over x. So in the first one, our ratio would be 9 over 3. And 9 divided by 3 is 3. Our next ratio would be 12 over 4. And 12 divided by 4 is 3. Our next one is 15 over 5. And 15 divided by 5 is 3. Can I stop? No, because you have to make sure the last one is the same. So our last one is 18 over 6. And 18 divided by 6 is 3. So when I look at all my k's and I see that they're all the same, this would mean it is a direct variation. So I would write this y equals 3x. There's my equation. Now we're going to go to table B. We're going to look at table B and we're going to see if table B is a direct variation. So I would look at my x and my y values. To find k, we do y divided by x. So I would do 12 divided by 3, and I would get 4. So then I would go on to my next one. 20 divided by 4 is 5. So what do we notice about our k values? They're different. So this would be not a direct variation. So let's move on to graphs now. When I'm looking at graphs, to tell if it's a direct variation, it has to be the same thing. So since direct variation is a proportional situation, this means the graph must go through the origin. And remember, the origin is 0, 0. So here's my origin, what I just circled in blue. Sorry. Here's my origin, what I just circled in blue. Is this line going through the origin? No. So this is not a direct variation. So we'll look at the next one. Here's my origin. Does this line go through the origin? Yes. And then the last one, here's my origin. Does this line go through the origin? Yes. So remember, when you're looking for a direct variation on graphs, it has to be a proportional situation, which means it goes through the origin. All right, now let's move on to equations. When you're identifying direct variation from equations, you're looking at if it has a plus or a minus. Notice that this equation here does not have a plus or minus, which means my y-intercept would be 0. All right? So that means it goes through the origin. Over here, I have a plus 9, which means my y-intercept is 9. We don't want this plus 9. This means it is non-proportional, so it would not be a direct variation. So which equation is a direct variation? Equation A is a direct variation. Okay, lastly, we're going to talk about when y varies directly as x, that means y equals kx. where k is the constant of variation. So we're going to look at this example. It says, in this equation, y varies directly as x. If y is 42 when x is 56, what is the value of y? What is the value of x when y is 18? So all you would do here is you would set up a proportion. So my proportion should be y over x, because those are the two things that we have here. My y value is 42 when my x value is 56. And this is going to be equal to 18, because 18 is my y value. And we don't know the x value, so we're going to put x. So we're going to solve for x. So what I would do here is I would cross multiply. So I would multiply 56 times 18. So we would do 56 times 18 equals 42 times x. So 56 times 18 gives me 1008. And 42 times x gives me 42x. I'm going to get rid of this coefficient by dividing by it. So I'm going to divide by 42. These would cancel. So 1008 divided by 42 gives me 24. So x would equal 24. If you have any questions, now's the time to write your questions at the bottom of your Cornell notes and ask them tomorrow during class. Have a great rest of the day.